In topic 1.4, we're going to be evaluating absolute value expressions and solving. This video focuses on evaluating. Absolute value is a number's distance from 0 on a number line. So anytime you have absolute value, they use the long lines. I think of them as boundary lines. That means absolute value. So if you have the absolute value of -5 on a number line, -5 is 5 away from 0. So the absolute value would be +5. The absolute value of +5, if you look at your number line, 5 is 5 units away from 0, so that's also +5. So absolute value is always positive. We're going to tie this into what we learned in topic 1.1, which was evaluating expressions. So here we're going to evaluate when x equals 6. So I'm going to start by plugging in -6 everywhere I see an x. Now I can work it out. Remember, absolute value becomes positive, so the absolute value of -4 is +4. Here, I need to simplify before I take absolute value. So -2 times 6 is -12. Now, if you take the absolute value of -12, it becomes +12. So my problem becomes 4 minus 12, which equals -8. In our next example, we're going to plug in -4 for x and 3 for y. Here, 2 times -4 is -8, and 3 times 3 is 9. I'm going to bring everything else down. So I'm simplifying what's on the inside first. Now, -8 minus 9 is -17. And at the very end, if I take the absolute value of -17, it becomes a +17. For these next examples, we're going to use -4 for w, 2 for x, 0.5 for y, and -6 for z. So I'm going to start by plugging in 2 for x here. Then I make my problem smaller. So 2 times 2 is 4. 4 minus 8 is -4. Now I can take the absolute value. Absolute value of -4 becomes +4. In this next problem, I have negative absolute value of 10. X is 2 and y is 0.5. So I need to start by simplifying the inside. 10 times 2 is 20. 10 times 0.5 is 5. Everything else stays the same for now. Now 20 minus 5 is 15. Now that I have my absolute value simplified, the absolute value of 15 is +15. But because it's negative separate, there's still going to be a negative in my answer. So the answer is -15. In my next problem, I'm plugging in a 2 for x and a -4 for w. So now I can simplify the inside. 2 plus 5 is 7. Here, 2 times -4 is -8. Now that the absolute values are simplified, I can take absolute value. So the absolute value of 7 is 7. And the absolute value of -8 is +8. And at the very end, I would subtract. So 7 minus 8 gives me -1. On our last example, we're going to plug in a -4 for w, a -6 for z, and a 0.5 for y. Now I can start to make things smaller. Here, since -4 is already small, I can take the absolute value. The absolute value of -4 is +4. And since there's nothing in between the 5 and the 4, that means we're multiplying. So it becomes 5 plus 4. In this absolute value, there's a lot of terms. If you're using PEMDAS, we need to multiply first. So 2 times 0.5 is 1. Here, 5 times 4 is 20. I want to make my absolute value smaller. So negative 6 minus 1 is negative 7. And now I can actually take the absolute value of negative 7, and that becomes a positive 7. So this becomes 7 times 2 plus 20. Remember, when you're using PEMDAS, you multiply before you add. So 7 times 2 is 14. And 14 plus 20 will give us 34 for our final answer.